Hi, Miss.
Hi guys, can you hear me well?
Yes.
Okay,
Yes.
all right. We're just waiting for people to join. How many were you? How many were you in the last session?
15. Hi, Miss Nisma.
Hi Najat. Where are the rest?
We are entering.
Okay.
I'm so bored.
So,
Miss, I'm so hungry.
Me too.
um,
What should I do بقى؟
Miss, aren't you hungry يا Miss؟ or حتى thirsty يعني حضرتك قاعدة بتدخلي حضرتك حصص وتعملي وحضرتك صايمة يعني الحد اللي مش فاهم حضرتك تزعقي له. أصلا Miss muted.
no, I heard her. Well, it's really just that I get in the mood of work, so I don't really feel hungry or thirsty. After finishing, I really feel hungry and thirsty.
Yeah, Miss, you know, yeah, Miss, يعني
Yeah, Miss, I don't get hungry, I get thirsty.
yes. مش عارفة ازاي.
Yes, Miss, I drink a lot of water في الأيام العادية and then during Ramadan بقى I feel so thirsty.
يا مس كأننا في الصحراء بس في أكل حوالينا يعني إيه في الصحراء في أكل إيه ده؟
امبارح بالليل شربت 5 ازاز ميه.
This is good. This is good. Anyway, so
Miss, I fell asleep before I could drink the water.
Oh,
I forgot to drink water. I only drank 1 cup.
Me too.
you have to drink
slept
water
all
very
the
well in Ramadan. It's very important that you drink water
Yes,
very
every day
well.
in Sahur, I fill 2 bottles and I keep drinking them. And then my stomach hurts me and I go to the toilet.
Yeah, you're not a camel. You're treating yourself like you're a camel.
يا مس we need to be يعني اشمعنى الكامل يعني الكامل اللي كان فيه بيصوم يعني كان المس يبقى عنده يبقى كأنه بياكل طول اليوم يعني.
Oh, okay. So let's take the attendance. Ali, is Ali here? No. Okay. Aisha.
No.
Aisha. Okay. Farida.
Here.
Hannah.
Here.
Hala.
Here.
Haya.
Here.
Khulud.
Here.
Thank you, Najat, for the heart. Limar.
Here.
Malak.
Here.
Mariam Walid.
Here.
Muhammad Ahmed.
Miss Ruqayya is still connecting.
Okay. All right. Mustafa. All right. Najat, she's here. Noor. Noor is not here. Ruqayya is connecting. Okay. Yasin Abdul Hamid.
Yes, Miss.
Yes.
You're here? Okay, Ruqayya. You're here?
Yes.
And Yasin Abdul Hamid is here. Yasin Tamer is not here. Yasin Radwan.
Here.
Okay. This is the first thing. The second thing is I am going to tell you who submitted the homework so that the people who did not submit the homework, please pay attention to the names. So we had 2 homeworks so far. The first homework was dated April 19th, which was page 23. The ones who sent the homework to me, pay attention, please. Those are the ones who sent the homework. I received their homework. Mariam Walid, Aisha, Khulud, Ali, Najat, Haya, Hala, Malak, Limar, Hannah.
Did you say my name?
No, please pay attention and do not interrupt me because this way the other people, yeah, please pay attention. Mariam, Aisha, Khulud, Ali, Najat, هايا، حلا، ملك، ليمار، هنا، مصطفى، ياسين عبد الحميد، رقية and فريدة أيمن. And I think the last 3 names, Yasin, Ruqayya, and Farida, you sent it to me in the weekend, right? Because
Yes.
yeah, okay. Please pay attention to the due date, okay?
This will I take the mark?
You will take the mark, but please pay attention.
Didn't have.
What?
I didn't have the book,
Okay,
but when I got it, I made it.
all right. Now the other homework that was on Thursday, April 22nd, page 37, the one that we're going to correct now. The people who sent the homework to me are Mariam, Hala, Yasin Abdel Hamid, Khulud, Yasin Muhammad Radwan, Limar, Malak, Haya, Aisha, and Farida Ayman. Okay?
I got to submit it because I had a problem in the internet and submitting.
Okay, submit it now, Ruqayya, so that I can, after finishing the session, I can check it and give you the mark. Okay?
Can I submit it now?
Yes,
Me too.
after the session, just focus on the
Okay.
session first, and then after the session, you can submit it. Okay?
Okay.
And Yasin Radwan, you did not submit the one on April 19th, huh? The one that was page 23.
Yes, I didn't have the book at that time.
Okay, please submit it so that I
Miss,
can
but I
give you a mark.
submitted the one on page 23.
Yes,
right?
I'm asking about I'm telling you everyone who submitted and who did not submit. You submitted the first one, but you did not submit the second one, Najat. Okay?
Okay.
All right, guys. So that was about the homework. So the first thing that we're going to do is correcting the homework, page 37. So please grab your resource pack and open page 37. Match each acid and alkali to where it can be found. This, I just want to show you how many times did this type of questions came, because you have several worksheets in your book that's asking about the slides that I keep telling you to memorize, okay? So this means that they are important and you have to memorize them. Okay, so yes, Aisha, I want you to do the first box, please. Hey, hydrochloric acid, where do we find hydrochloric acid?
D, mammalian stomach.
D, mammalian stomach, yes. What about the lactic acid?
E, muscles after vigorous exercise.
Yes, E, muscles after vigorous exercise. Uric acid?
F, urine.
Yes, methanoic acid.
C, in an ant sting and nettle sting.
Very good. Citric acid.
B, lemon juice and orange juice.
Very good. Tartaric acid.
G, grapes.
G, grapes. And the ascorbic acid.
A, citrus fruit and black currants.
Very good. Okay, thank you, Aish. Okay, did you do it this way, everyone? Huh?
Yes.
Okay, let's do the next box. Who would like to do the next box? I will pick someone from the people who are raising their hands. Yes, Yasin Muhammad Radwan. Huh? The next box.
Hydroxide and potassium hydroxide solution used in laboratories. Calcium hydroxide is used in industries to make bleach and whitewash. Weak solution of calcium hydroxide, lime water. Test for CO2.
Okay, very good. So sodium hydroxide and potassium hydroxide, C, used in laboratories. Calcium hydroxide, the concentrated solution, which has another name, which is lime, is A, used in industries to make bleach and whitewash. And the last one is weak solution of calcium hydroxide, which is called lime water, used for testing for carbon dioxide in breath. Thank you so much, Yasin. Okay, guys, so we're going to continue. I think there was a page that we started answering and we did not finish. Am I right?
We finished it.
We
Yes,
finished.
You said you will see the colors again for the people who didn't.
Yeah, okay, I will do the colors again. It was page 24.
24.
Yes, page 24. I'm going to color them again.
Miss, we
okay?
finished it, and I did it.
Yeah, some people did not, they didn't have the time. Okay, so again, please mute your mics, guys, because my ears are hurting me. Thank you.
Miss, my mic is not on.
Okay, hydrochloric acid, when you add it to red cabbage, it changes its color to red. So we're going to color it red, okay? Sodium hydroxide, when we add it to the litmus, it changes its color to,
Can I say it? Green.
with litmus,
Miss, you said that last time. Green.
sodium hydroxide with litmus. Did I say green?
Yes, you said green.
The rest of you guys, did I say
No,
green?
blue.
No, I said blue.
No, Miss, I did it blue. It's blue.
Yes.
Blue.
Najat, wake up.
Yes, I heard it. I heard it green.
Fix your ears.
Yeah, Najat حتى Miss colored it blue.
Okay, so it is.
Miss, I remember how we did.
Okay, so it is blue. Hydrochloric acid with
This is like this.
hydrochloric acid
the
with
blue, the red, then blue, then red, then red, then yellow.
okay, okay. Hydrochloric acid with methyl orange gives red color. Yes, beautiful, Ruqay. Very nice. Hydrochloric acid with litmus is also going to be colored red. Sodium hydroxide with methyl orange is going to give us a yellow color. So we're going to color it yellow. And the sodium hydroxide with red cabbage, this is the one, Najat, that is going to give us green color. Okay? Green. Yes. Okay. So I just wanted to repeat this for the people who did not who wasn't able to do it with us. Okay. So someone joined us. Nuran Yasin Tamer, are you there? Please mute your mic, Hala. Nuran Yasin Tamer, did you join?
Yes, Miss.
Okay.
Yes.
So Yasin and Noor are there. Okay. Now, I'm just looking for if there is any other worksheets that we can solve before going to, I think we can do this. No. We're going to continue with our lesson, guys. We talked about the phenolphthalein, right? The phenolphthalein and the methyl orange. That was the last thing that we do together, right?
But Miss, can you repeat the final this thing? Because it's still, I cannot.
You cannot what?
Miss, I'm still confused in it.
You're confused about what, Najat? I would love a specific question. I would love a specific one. You just don't remember them, don't you? Because the whole indicator thing is just changing colors. There is nothing to understand. Is anyone else have a problem with the indicators?
No, but Miss, are we supposed to?
Yes, you're supposed to. You're supposed to memorize.
Understand the meaning of indicator.
Oh dear God.
Miss, I understand everything.
I know.
Are we supposed to
You're supposed to
these two?
memorize. Yes, you're supposed to memorize their names, the names of the indicators that we have studied, and the change in their colors. Okay? Because this is how the question comes. They ask you about the name of the indicator and what change in color occurs in them. The indicator, Ruqayya, is a dye or a chemical that changes its color when it reacts with the acids and the alkalis. They are called indicators because they indicate the presence of acids and alkalis. Without them, we cannot detect acids and alkalis. We will not know, we will not be able to know the difference between acids and alkalis. We talked about 4 indicators so far. We talked about 4 indicators. The first indicator that was discovered by a scientist called Robert Boyle, which is an Irish scientist, is the juice of the red.
We have to memorize his name.
Yes.
What's his name again?
Robert Boyle. It's already in the PowerPoint, and when you, I hope that you go through the videos again by the end of each week, maybe on Thursday or something, just go through the, listen to the videos again, okay? And every day, the part that we talked about, every day, just like the 2 or 3 slides that we have learned. Really, seriously, guys, that would help you a lot. Instead of waiting till the end of the trimester and start going through the whole thing again, especially in this lesson. This lesson must be, as I told you several times, memorized and studied day by day. Okay? So again, the scientist, the one that started the idea of the indicators, is an Irish scientist called Robert Boyle, and he used the juice of the red cabbage, and he realized that the actual color of the juice is purple. When he adds acid to the purple juice, it turns red. When he added alkali to the purple juice, it turned green. This is the first indicator. So what's the meaning of an indicator? It's the dye or the colorful chemical that changes its color when it reacts with alkalis or acids. And you can say that 75% of the indicators are plant-based, which means that we extract them from plants. And only 25% are made in the laboratories. Like what? Like the methyl orange and the phenolphthalein. Okay, so the first indicator is the purple or the red cabbage juice. Its color is purple. Okay, the second indicator is the litmus, and we said that the litmus could be a solution or strips. They could be strips and they could be solution, made into strips or solution. They have 3 colors actually. There is the purple color, the one in the middle, but we don't use this anymore because it gets confused. We get confused between it and the solution that we add an alkali to it. You can see that the colors are very similar to each other. So we stopped using the litmus, the purple litmus. The 2 other colors that we use and that they make a real distinct colors are the red litmus and the blue litmus. Okay, so we have 3 colors of litmus: purple, red, and blue. Purple, we can use it, but it will be a little bit confusing for us to use it, especially when we add an alkali to it, because of how much the colors look like each other. So we started using the other 2 colors of litmus, which are the red litmus and the blue litmus. Okay, and the litmus is a type of plant too, Ruqay. All right, so this is the litmus solution, the purple one. When we add acid to it, it turns red, maybe orange, and when we add an alkali to it, it turns blue. Okay, now what about the red and the what?
Can you, at the end of the session, see if my homework came to you or no? Page 37.
Okay, if I have time. Now, with the other 2 colors of the litmus, which are the blue litmus and the red litmus, they are much better at detecting the acids and alkalis because the color change is really obvious. The color change is really obvious. We have the blue litmus. It is used to detect the presence of the acid in a solution. And we have the red litmus, which helps us detect the presence of alkali in a litmus. How? the blue litmus, when we add acid to the blue litmus, it turns red. And when we add an alkali to the red litmus, it turns blue. So the difference is very obvious. Okay? Now, as I told you last time, we have 3 types of solutions: acidic solution, neutral solution, and alkaline solution. The neutral solution is the solution that is not acidic or alkali. Like what? Like water. Water is not an acid and it's not an alkali. Okay? So now I have an acidic solution and I have 2 litmus papers. One is red and the other is blue. If I added the acidic solution to the red litmus, will it change its color? If I added the acidic solution to the red litmus, will it change its color? No one?
Miss, can you repeat the question?
Miss, what's the question?
Again, I said it for like 3 times so far. I have an acidic solution and I will add this acidic solution to a red litmus paper. Will it change its color?
Will turn blue.
Oh, seriously?
No, it will not change. No,
No,
it will
no,
not.
it will not change.
It will not change because the red litmus
the same.
paper, the red litmus paper turns blue only with an alkali.
Alkaline.
Okay? So this means that if I added, thank you, Mariam, if I added an acidic solution to a blue litmus, will it change its color? If I added an acidic solution to a blue litmus.
Yes,
It will change to red. Very good. Now, what about the neutral solution? If I added the neutral solution, whether to the red litmus or to the blue litmus.
Miss, now you're talking super fast.
Miss, nothing will happen.
Thank you. Thank you, Yasin. So if I added neutral solution to the red litmus or the blue litmus, nothing will happen. They will not change. The color will not change because it's not an acidic or an alkaline solution. Now, the last solution is the alkaline solution. If I add it to the red litmus, will it change its color?
Yes.
It's going to turn into blue. But if I add it to the blue litmus, it will stay blue. Thank you so much, Hala. Okay? Very good. Now, the last 2, this is the way that you can remember the names. We're going to start with the acid. The acid turns red. The acid turns red. The next one is the alkali. The alkali turns blue. So when you collect all the initials, they make the word Arab. And we always start, the first A always starts with an acid. Acid turns red. Alkali turns blue. Okay? The last 2 indicators are the ones that I told you if we make them in the lab, are called methyl orange and phenolphthalein. Okay? The methyl orange turns pink when we add an acid to it, and it turns yellow when we add an alkali to it. The phenolphthalein. Ruqayya, you have a major problem with your internet connection. I cannot hear anything. Say it again.
Yes, 20 minutes.
Can you send it to me in the chat, please, Ruqayya? Would you send the question in the chat? Send the question in the chat because you're lagging. Okay? So again, the methyl orange is orange. It turns pink when we add an acid to it. It turns yellow when you add an alkali to it. The phenolphthalein turns colorless in acid solutions and it turns pink in alkaline solution. Okay, guys, is it clear? Yes. Okay, can I move on?
Yeah. Yes.
Can I move on? Okay. Okay, Ruqayya is sending me her question. I was saying, how do we memorize the spelling of the second indicator? Phenol, phthalene. Just do it. You're old now. You can memorize them. Okay. So the pH scale. What is the meaning of a pH scale? Okay. Now I need you guys to pay an extra attention to this part. We said that we have two things that we are talking about since the beginning of this trimester that are called acids and alkalis. Okay. Now the scientists wanted to put a scale to how strong the acids and alkalis are, because I told you at the beginning that we have strong acids and we have weak acids, and we have strong alkalis and we have weak alkalis. And this is why some acids we can actually eat or drink it, and some others we cannot. So this means that there are different strengths in the acids and alkalis. So how can we make this scale? So there was this Danish scientist who in 1909, his name is Søren Sørensen. His name is funny actually, Søren Sørensen. And Søren Sørensen invented a scale called the pH scale. And pH stands for power of hydrogen. Okay, pH scale, pH stands for power of hydrogen. He used this scale to arrange the acids and alkalis according to how strong and how weak they are. Do you understand so far, guys? Do you understand the concept of the pH scale and why did Søren Sørensen made this scale?
Yes.
Okay, Ruqayya, what about the rest?
Yes, Miss.
Okay, so again, Søren Sørensen was the first scientist to come up with an idea of arranging the acids and alkalis according to their strength, because we know, or we noticed, that we have some strong acids and some strong alkalis and some weak acids and some weak alkalis. So we need to arrange them in a scale. So we call this scale the pH scale, and pH stands for power of hydrogen. Okay. Now, what is the idea of the pH scale? Look at this beautiful scale with beautiful colors. Okay.
Very beautiful, Miss.
Yes, is exactly. So we're not going to start from the zero. We are actually going to start studying the pH scale starting from right here, the middle, the exact middle of the scale. Okay, the scale has the numbers from 0 to 14. We are going to start studying it from number 7. Why did I choose number 7? Because number 7 is the pH, the power of hydrogen, or the number that we give to the neutral chemicals. Like what, guys? Like what neutral thing did I tell you?
Water.
Like water, exactly. Thank you, Yasin. So yes, water was actually put on the scale as one of the chemicals that we compare acids and alkalis to. Why? Because it has a pH scale equals number 7. We give it number 7, which is right in the middle between the acids and the alkalis. So this means that any chemical that has number 7 on the pH scale is not an acid and is not an alkali. Do you understand why did I start studying the pH scale from number 7?
Yes.
Huh? Do you get the idea why did we start studying the scale from number 7?
No.
Huh?
No.
No? Okay. Again, we have something called the pH scale. The pH scale shows us how strong, please mute your mics, how strong and weak acids and alkalis are. Okay? How strong and weak acids and alkalis are. Okay? The scale has numbers from 0 to 14. From 0 to 14. What is the middle of the pH scale? What number is right in between or right in the middle of the pH scale?
7.
Number 7, right? Number 7. Number 7 represents any neutral chemical. Any chemical that is not an acidic and is not an alkali. Like what? Like water. Water has a pH of number 7. This means that any chemical in the world that its pH number is 7, this means that it's not an alkali and it's not an acidic. It's not this or that. It's neutral. Okay? Anything below number 7 will be an acidic solution, and anything above number 7 is an alkaline solution. Again,
What is 7?
huh?
7 is acidic or
I
alkaline?
was just talking about this, Hala. I just repeated it. 7 is not an acid and it's not an alkali. It is neutral, not an acid and not an alkali.
Neutral, okay.
Okay, it's neutral, like what? Like water, okay? Number 7 is not an acid and it's not an alkali, and this is why it's right in the middle between the acids. The acids is everything that has a pH below 7. So from 0 to 6 are considered acidic solutions, and from 8 to 14 is considered what?
Alkali.
Yes,
Alkaline.
an alkaline solution. So we have something, by the way, we have a device that we use in the lab, which looks like what? Looks like a USB. It has a sensor at the end of it, and you put this device inside the solution. You put
Miss,
this.
you said that today you will get the things from the lab and you will show us how
I am at
to-
home, dear. That will be on Tuesday, on Wednesday. Yes, maybe next Tuesday or Wednesday. I don't know. You have a session on Tuesday? Do you have a session on Tuesday? No.
No,
You have a session on
no.
Wednesday. So most probably
Okay.
on Wednesday, yes, I will show you things.
Okay.
Okay. So we have this device that you put inside the solution. Okay, and this device gives you a number. This number is the pH number. Okay, so for example, if you have a solution and you put the device in it and it gives you number 3, this means that the solution that you just tested is an acid or an alkali?
Acid.
Excellent, thank you, Yasin. Do you understand, guys?
Yes.
Okay, let me try another thing. I brought a solution. I don't know what this solution is. Is it an acid or an alkali? So I will put the device inside the solution. It will give me number 11. This means that this solution is what?
Alkaline.
Is an alkali. Excellent. Now, if I brought a solution and I put the device in it and its pH is 7, this means that this solution is what?
Neutral.
Thank you so much. This solution is neutral. Okay, so if the solution has a pH of number 7, this means that this solution is neutral. Anything below number 7 from 0 to 6 is an acid. Anything has a pH above number 7 from 8 to 14 is an alkali. Okay? All right?
Okay.
Should I skip to the next point? The next point most probably will be the last point. Okay?
Miss, how do we have the meeting says we have 4 minutes left, and on real life we have only 9 minutes left?
Because this session is only 40 minutes. The Zoom session is always 40 minutes, but in the timetable, in the schedule, your schedule, you will realize that the last 2 sessions are 45 minutes. But unfortunately, Zoom
Yes, but
can
how
only.
the Zoom session is 40 minutes. When I do Zoom, it can be 2 hours.
I don't know. The sessions that we use
Okay.
are 40 minutes. Yes. Okay. Now I want you to pay a very good attention, because this is a little bit.
Some people pay money to
No, but I don't pay money.
Okay. Let us just get back to the session, please. Okay. Now I want you to pay attention.
Okay.
I want you to pay attention to the next point, because it's a little bit confusing. Okay. Please pay attention and mute your mics and pay
A
attention.
little bit, Miss, a little bit.
Najat, no time for
Okay.
kidding. Okay. Mute your mic. Now, in the scale, I told you that they use this scale for what? For determining or identifying how strong the acids or alkalis are. How strong the acids or the alkalis are. Okay, before I give you the answer, I know that it was already written. Okay, but before I give you the answer, we know that any solution have the pH from 0 to 6 is an acid. Okay, now my question is, the strongest acid will have a pH of what? From 0 to 6. Pick a number.
0.
The strongest acid will be the solution
0.
that has, yes, pH 0. This is why I'm telling you that it's a little bit confusing, but it makes sense. Look at the scale again. I told you that number 7 is the what? Neutral solution. It's not acidic. Yes, and it's not acidic and it's not alkali. So this means that if we are walking on the scale, please mute your mic. If we are walking on the scale, imagine that you're walking on the scale from 0 to 6. You will find that the acid keeps getting weak until it turns into what?
Neutral.
Neutral. It turns into water. So this means that it's getting weaker the more that we walk on the scale from 0 to 6. The acid keeps getting weaker and weaker and weaker until it turns into water. It turns into a neutral solution. It's not acidic anymore. Do you understand, guys?
Yes, and the meeting will.
Okay, so I'm going to start from this slide tomorrow, because it's going to end right now, the session. Okay, I'll be seeing you tomorrow, guys. Bye.
Bye.